Hello, my name is Johnny Huang, and I am currently a master's student with the EPS department. And my field of study is in atmospheric sciences, so more on emissions verifications and carbon dynamics and captures. But I have been a GSI for EPS C20, which is the earthquakes class on this campus. My current research is in carbon dynamics and carbon capture, so it has a lot to do with the emissions and fossil fuel emissions. And what I've been doing is creating some sort of a verification for those emissions, and yeah, that has been the basis of and theme of my master's program here. However, in terms of earthquakes, I have been a GSI, a graduate student instructor with the EPS C20 course. That course is called Earthquakes in Your Backyard, and it is an introductory course on earthquakes and seismology for a lot of the students here at UC Berkeley. With the EPS 50, I have taught that this semester, the spring semester of 2025, and that class is basically an introductory class for a lot of the Earth and planetary science majors here at Berkeley, and it covers a wide range of topics from the oceans to the atmospheres to the planet Earth and earthquakes. And so that course, we had a section in the class where we talked about earthquakes and seismology. However, for a more detailed class, I taught EPS C20 in the fall of 2024. And in that class, it is a Earthquakes in Your Backyards class, so it's an introductory earthquakes and seismology class. And yeah, the students here get introduced to what is an earthquake, why should we care about earthquakes, and what to do in case of an earthquake and how to prepare for them. With the MyShake app, the goal of it seems to be having some sort of a early warning for these earthquakes, and so for citizens and for individuals to know when an earthquake is coming. And so with the MyShake app, what I've been taught about it is that they basically receive some sort of a signal from the earthquakes, so earthquake P waves that arrive at the seismograph first, and signifying that and notifying citizens that an earthquake is coming. With this one, I will draw from my own experiences with this, so things that I say could be a little bit inaccurate, but from what I know, the app is largely majority created by Richard Allen. So this is the professor that teaches the EPS C20 class in the fall, and so he has created this app to serve as an early warning. A tool to notify individuals about when an earthquake is coming. And so with the MyShake app, it is quite, I feel has a quite fun way to use. It's sort of like the USGS kind of earthquakes now map, but the main thing, if we are talking about the goal of the MyShake app, it seems to be to alert residents or citizens early about an earthquake. And so what could happen is if it detects a really big earthquake, for example, last semester we had a magnitude 7 earthquake that happened around in the Mendocino Triple Junction, around this area over here. It gave out a warning for the earthquake. So it had this very loud blare, this kind of almost like alarm and siren kind of sound that was emitted from my phone that said like magnitude 7 earthquake, please prepare or duck and cover. And so this is a really, I feel, a very useful tool to maybe at least have a few seconds, few seconds to maybe like 30 seconds of warning to prepare to make sure that I am safe underneath a sturdy table, and so that hopefully with the goal of minimizing casualties and maybe even injuries to citizens and individuals. Yeah, I think this app is great. It currently, I feel like, features state-of-the-art.
So my name's Richard Allen. I'm a professor in Earth and Planetary Science here at UC Berkeley. My research interest is in seismology. And so the big class that I teach is actually called Earthquakes in Your Backyard. And so it's teaching undergraduates all about issues related to earthquakes and the effects that they have on society. So my undergrad was actually in natural sciences. So I studied multiple natural sciences. I studied geology, I studied physics, chemistry, material science, and mathematics. And the piece that I was really interested in was the physics part and then the geology part. And so that's what led me to geophysics. So then I went on to do a PhD in seismology, where I was doing research on earth structure. So I was imaging the Earth's interior, understanding how hot material comes up from deep in the Earth's mantle, up beneath the North Atlantic. The Iceland plume specifically was what I was researching in. But then as time went on, I got more and more interested in the earthquake process itself, and that's what led me to becoming interested in earthquake alerting and earthquake early warning, which is what most of my group spend their time doing research on now. So the Hayward Fault, which goes right across the Berkeley campus here, is one of the most dangerous faults in Northern California. We estimate that there's like a 1 in 3 chance of a major damaging earthquake on that fault in the next 30 years. And if you look in all of the Bay Area, it's about a 2 in 3 chance in the next 30 years. So the Hayward Fault is a pretty high risk situation. Last time we had an earthquake there was 1868, the same year that UC Berkeley was actually founded. And the average recurrence interval on that fault is 150 years. So we've actually gone past the average recurrence interval. So we really have to be ready for an earthquake on that fault at any moment. So the reason it's the most dangerous fault is because it has a relatively short recurrence interval, 150 years. That's relatively short, geologically speaking. We are overdue. We've passed that 150, which means that there's a higher likelihood of an earthquake. But then what really makes it dangerous is its location. So the Hayward Fault goes through the East Bay, goes beneath Berkeley, beneath Oakland, Fremont, Hayward. So there is a lot of people and a lot of property built directly on top of the Hayward Fault. So when that earthquake occurs, and it will occur, it's going to do a great deal of damage to the East Bay. So the studies that really look at the hazard are paleoseismic studies. So these are studies where you go and you dig trenches across the fault and you look at little pieces of charcoal and you do carbon dating on them in order to understand when those past earthquakes have occurred, and by seeing the sequence of past earthquakes we can estimate how frequently they occur. That's how we get to 150 years. But that's not what I do. I'm a seismologist, and so I use seismic data to study earthquakes. So seismic data is the energy that radiates away from the fault plane whenever an earthquake occurs. So I can't study an earthquake that happened 300 years ago. We don't have any data. But what we can do is we can study earthquakes that happen today. And so that's what's led to our earthquake early warning system. Is we developed algorithms that very rapidly detect when an earthquake starts. We locate the earthquake, we estimate the size of the earthquake, who will feel the shaking, and then we send out a warning to people. So that's the data we collect, is these vibration, the energy radiating from a fault as it starts to rupture. And we use that to assess very quickly who's going to feel the shaking so that they get the warning before they feel the shaking. So the MyShake app was built originally as a citizen science app. So in everybody's smartphone there is an accelerometer, the same sensor that we have in our seismic networks to record ground shaking. And so the idea was very simply, let's harness the accelerometer in everybody's phone to record earthquake shaking. So we built an app and people downloaded the app, and we would be collecting data about earthquakes from the app, which was great. The app then evolved because we built this earthquake early warning system so it would actually receive the alerts and so present the alerts, the warnings to the app, to the phone owner. So it became primarily an earthquake early warning app sponsored by the state. State of California funds the app to deliver these earthquake early warning alerts. So of course that's why most people download the app. But still the app is collecting seismic data as well. So it's actually feeding data that we use to understand earthquake processes. So we've tried to build something where it's an app, it's on people's phones. So we want it to give users something useful, the earthquake early warning. But at the same time, the app collects data that we can use to understand earthquakes and hopefully do a better job of protecting people for future earthquakes. Right, exactly. Yeah. No, so it's meant to be an earthquake information tool. There's safety tips on the app. You can actually record, you can see the seismograms that you're recording on the app. And then, of course, you get the alerts. So you can drop cover and hold on when there's an earthquake. Well, first of all, the first thing is that everybody who lives in California needs to understand they are going to be affected by an earthquake in a major way. We know that there's a very high likelihood of large magnitude earthquakes in both northern and southern California. So we all have to recognize that risk. So then what should we do about it? Well, step number one is download MyShake. That way you get warnings when there's an earthquake, but also there are safety tips. So look at the safety tips in there. Those safety tips tell you about how to prepare for an earthquake. So you should have a plan. First of all, you should know that when you either feel shaking or you get an alert, you do drop cover, hold on. You get under a sturdy table to protect yourself from things falling on you, reduce the likelihood of injury. But then also you need a preparedness plan of how you're going to react immediately after the earthquake. You're going to need to meet up with family members. You need a plan for how you're going to meet up with family, whether you have kids who are at school, where are you going to meet up with them? Are you going to go get them from school? Are you going to meet up with them somewhere else? Other friends and family, how are you going to coordinate? You need to have an emergency kit. So you could be isolated without any help from outside for 3 to 5 days. So you need to have water, you need to have food, you need to have medical, like first aid kit and things like that. So you need to have a preparedness plan for where you're going to go, how you're going to meet up with your friends and family, and then you need to have gear, the kit, so that you can look after yourself and your friends and family for the next 3 to 5 days. So that's really important. And then beyond that, once you have that emergency kit, you should think about the buildings that you live and you work in. Are they safe buildings in an earthquake? We know how to build buildings that don't collapse in earthquakes. So modern buildings are seismically safe so that they should not collapse. However, old buildings are not necessarily seismically safe. So you should learn about the building that you're living in, the building that you're working in, see how seismically safe it is, and see if you can take steps to improve the seismic safety of the building. So again, it's very simple. Buildings that are new are safer because we've made great advances over the last few decades in improving seismic safety. So buildings that have basically been built since the 1980s are much better than buildings built before the 1980s. So you're better off if you're in a newer building, but we can also retrofit older buildings so that they are also equally safe. So it's not just that the only buildings that it's safe to be in are the more recent ones. Other buildings that have been retrofitted are also relatively safe. So the building we're in here, the Department of Earth and Planetary Sciences, has been retrofitted.